Hi, everyone. So, one part of our course is going to be learning and practicing some problem solving skills involving math. And this is kind of the first lesson in that component of our course. I want to review some basic definitions for complex numbers. I think when you were introduced to this idea in high school algebra, you saw something like what you see here. Now, generally, what happens is that this idea is introduced in 10th grade, and then you don't really come back to it much for like 4 or 5 years. And when you first learn about it, maybe it's not clear why it's important or why you would care about a topic like this. Now that you've reached the current point in your education, having completed Calc 2, you are ready to learn why these numbers are important. And one of the things that we are going to talk about is how these imaginary numbers apply to different physical problems. And we're actually going to see there's a large number of applications for this idea. So the first thing we're going to do, I'm going to start with a review of some of the basics that you learned in high school algebra, just because I think it might have been a few years since you've worked on them. So when you first saw imaginary numbers, I think you saw them in the context of a problem that looked something like this: a solution to a polynomial equation. So we would say that the number I is a solution to the equation that you see here. The steps that I would use to justify that statement are laid out on the slide. Now, don't worry if you don't remember all the details at this point. That's one of the things that we're going to review coming up. So when the number I was first introduced, it was around 1500, and it was introduced in the context of a problem like this. So we can see algebraically that the number is a solution to this problem, but it's not really clear if this is physically meaningful. Like if my function was measuring meters, well, does it make sense to talk about a quantity of I meters? All right, so here's our first definition. The number I, that's a number with the property that I squared equals -1. Now when we use this, we put it together the way that you see here. We call this a complex number, and it's made up of a real part and an imaginary part. So it's a plus bi. The number a is real. Notice it's by itself. The number b is also real, but it's being multiplied by I. So that term in our expression is the imaginary part of my complex number. I put here a few examples of specific complex numbers that you might see. So notice that the real part of our complex number could be an integer, it could be a fraction, it could be some other kind of real number like a square root or pi. The next thing we want to talk about, we have two functions we use with complex numbers, like the real part of z and the imaginary part of z. Let's take a look at how we would use these functions on an example. So I'm looking at the complex number 2 plus 3i. If I apply these functions, the real part of that complex number is 2. The imaginary part of that complex number is 3. And notice that that function im is giving me 3 as the output and not 3i. If we're going to use that function, we do expect that the output will be a real number, not an imaginary number. One more example. So here I have the number z equals 7. I want to know the real and imaginary parts of this number. You see those here. In question, do you understand why the imaginary part of the given number is 0? Well, it's because we could write the number z, if we were going to write that in standard form a plus bi, I would write 7 plus 0i. So even though my original number doesn't show an imaginary part, there's an unwritten 0 that I can put in. Okay, so anytime I have a real number, it's also a complex number. It just has a 0 imaginary part. The next thing that we're going to talk about is the geometry of complex numbers. It's possible to picture them as points in the plane. And we do this, the real part gives us the x coordinate of the point. The imaginary part gives us the y coordinate of the point. And it turns out that visualizing complex numbers in this way is going to be useful to us. It's going to help us understand what's going on in some of the problems that we have coming up. Let's take a look at an example of graphing complex numbers. So the first number I want to graph is 1 minus 3i. I did that here. So the x-coordinate is given by the real part 1. The y-coordinate is given by the imaginary part minus 3. Second point. Let's take a look at the graph of minus 2 plus 2i. Okay, you can see that point graphed here. I have the real part, negative 2 is my x-coordinate. The imaginary part, 2, gives me my y-coordinate. There is one more definition that I want to talk about. It's called the complex conjugate. To find the complex conjugate, we take a complex number and we change the sign on its imaginary part. Let's take a look at an example. First complex number I have, z equals minus 2 plus 5i. I want to change the sign just on the imaginary part. The conjugate is minus 2 minus 5i. Next. Okay, I have 1/2 minus root 3 over 2i. Notice that in this example, I'm starting with a negative imaginary part. And so when I take the conjugate, that negative is going to turn positive. You see the result here. Last example. What about the complex number z equals minus 7? It turns out the conjugate here is also minus 7. Do you see why that would be the case? In order to break down the steps, well, let's rewrite this number. It's minus 7 plus 0i. Then when I take the conjugate, I change the sign just on the imaginary part. Notice that the real part stays negative. It's still negative 7. I change my plus 0i to a minus 0i. But 0 is a special case. Minus 0 is still 0, and so the conjugate simplifies down to minus 7. All right, so that was some examples of finding the complex conjugate of a complex number. One of the things that we're going to work on in the next lesson is finding the product of a number and its complex conjugate. I have one example laid out here. This is something that you did see before. I'm curious. Maybe check and see if you remember the details, if you remember why this is important. We're going to return to this topic and kind of fill in all of those pieces in the next lesson. Okay, so now that you've done this quick review, the next thing to do is to follow up by practicing these ideas on a few problems. So here are the ideas that we talked about in this video. And for all of these things, I have a worksheet with some problems that you can download and take a look at. So you want to be able to use all of the definitions that you see here, and you want to be able to graph a complex number. All right, give it a try. See what you think.